Let's talk about production cost. Let's fine-tune the cost curves that we're going to be using for our market structures. First one I want to talk about is fixed costs. FC. Again, please get used to the acronyms. So total fixed costs, FC. Now these costs, fixed costs are those costs that will not change with output. So fixed costs are those costs that will not change with output. So output is 0, you gotta pay these costs and pay a certain amount. Output changes to 10 units of the good, you still gotta pay these costs and pay the same amount. Output changes to 1,000 units, you still gotta pay these costs and you're still paying the same amount. Fixed costs. No matter your output level, you gotta pay these, and usually you're paying the same amount no matter your production. Can you give me an example? Which one? If I want to produce more, I gotta hire more people, so my wage bill will go up. Yeah? A very good example is rent. You sign a 10-year lease, you can't go and say, I didn't produce anything this month, so rent is free. Well, you could, but you're still gonna get evicted. Right? So a very good example is rent. Sign a 10-year lease, you produce nothing, you still gotta pay it. The capacity of the place is say 10,000. If you produce 1,000, you still pay whatever you signed on that 10-year lease. You go up to 3,000, still pay whatever you signed on that 10-year lease. So a very good example usually is rent. The other type of cost that we have, that we're going to be looking at, is total variable cost. And these are your VC. Again, please get used to the acronym. Total variable cost, VC, or sometimes TVC, but I just call it VC. Now variable cost, these vary directly with output. So output goes up, these costs will go up. Output goes down, these costs will go down. Output is 0, these costs are 0. Give me some examples. No, the wages. You said which one?
Supplies.
Yes, I agree.
Utilities.
Absolutely. Yeah? Variable costs. As you produce more, these costs tend to go up. As you produce less, these costs tend to go down. And usually the case is with variable costs, output is 0, these costs are 0. Here's another type. Total cost. How do you think we denote this one?
Fixed cost plus variable cost equals
There we
total
go.
cost.
Very good. TC, you add the fixed costs and the variable costs. Good. Right? So total cost, take your fixed cost and add it to your variable cost, and that's total cost. TC is equal to FC plus VC. Let's look at some more. Let me graph these first. Let's do that. So here's your output, or your quantity, and we're going to put cost here. Let's graph these three first, and then we'll look at some more. Fixed costs, they don't change with output. What do you think the graph looks like? Very good. Horizontal lines. Very good. Doesn't change with output. Variable cost varies directly with output. Excellent. Positive slope, it's not really linear, so it has a little bit of a curve on it, or slopes upward. Add FC and VC together, you get TC. So here's the TC. Also upward sloping and kind of sort of takes the shape of the VC. Now notice when output is 0, your total cost is equal to your fixed costs. But even when you produce nothing, you're still fixed. Remember that 10-year lease you signed? You still gotta pay it. So when output is 0, your total cost is still equal to your fixed cost. That's why we started up there rather than at 0. And it slopes upward. And really the distance between here and here is really your fixed cost. Okay? Let's look at some more. Let's look at some per unit cost. I'm going to continue with the list. But now we're looking at some per unit cost. Kind of like what we call average cost. First one we're going to look at is, let's do the average fixed cost. And it's just like any other average. If you want an average, you take the sum or the total of the stuff and divide by the number of stuff. So average fixed cost, again, please get used to how we denote it, AFC, average fixed cost. You take the total or the sum of the stuff, which is the fixed cost, and divide by the number of stuff, which the number of stuff you made, which is the quantity. So average fixed cost is fixed cost divided by quantity. FC over Q. Then we have average variable cost. Just like any other average, take the sum of the stuff and divide by the number of stuff. That's your average. So if I want average variable cost, how do I calculate this?
VC divided by the quantity.
Very good. AVC, take the total variable cost, divide by the number of stuff, which is the quantity. Average total cost. How do we denote this one?
FC plus VC divided by
ATC.
Yeah? No. Sometimes you'll see me denote this as AC. Please be aware. Sometimes I drop off the T. So when you don't see the T sitting in there, average cost. Remember I'm talking about average total cost. Sometimes I write ATC or sometimes you just see me write AC. Be aware. Formula wise, just like any other average, it's a total cost divided by the quantity. What's total cost?
FC plus VC.
So total cost, we have it here. Yes? So total cost. Yeah? It's the same thing, right? Yes? What's FC upon Q?
Average fixed cost.
Yes? And what's VC upon Q?
Variable cost.
What is algebra? Let it feel like I read econ class. Yeah? So we know total cost is fixed cost plus variable cost. We just simplify. So average total cost is the same as average fixed cost plus average variable cost. Okay? One more definition and then we graph them out. So one more. Very important cost is called marginal cost. So marginal cost. Now let me give you a definition. This is a change in total cost So marginal cost is the change in total cost when an additional unit of the good is produced. So produce an extra unit of the good. What's the extra cost you pick up? That's your marginal cost. So we're producing this in this classroom. Our total cost is 200. We decide to make an extra desk and our total cost moves up to 210. The change in our cost, because we decided to increase production, is 10. So the change in your total cost, because we decide to make an additional unit of the good, that's your marginal cost. So formula-wise, MC is the change in total cost divided by the change in quantity. Change in your cost because you've decided to make an additional unit of the good, that is your marginal cost. So MC is equal to the change quantity. That's what the formula is. Extra cost you pick up when you decide to make an extra unit of the good. Okay? Let's graph all of these out on one. Let's graph this out. Let's start with the AFC. What was the example you gave me of fixed cost again?
Rent.
Very good example is like rent. Okay? Now, let's say the rent is $100. So the fixed cost, $100. Remember, it doesn't change with output. Okay? Now, if we produce 1 unit of the good and the fixed cost is $100, what's the average fixed cost?
$100.
Yes? What about if I produce 2 units of the good?
50.
What about 3? 4? No. As I am increasing output, making more and more of the good, what's happening to my average fixed cost? It's getting smaller and smaller and smaller. Which means if I want to graph this out, as my quantity is increasing, I'm making more and more of the good, the average fixed cost starts off high and then it gets smaller and smaller and smaller and smaller. That's my AFC. Shape's a little funky and we could keep going. That goes into infinity where it gets closer and closer and closer to the quantity axis, but it never really becomes 0. But it's a funky shaped curve. Anytime I do this, that's the only cost curve that looks that way. You should immediately process, oh, that's the average fixed cost. Because it's the only cost curve that looks that way. I don't have to label them. You should know that's the AFC. Starts off high, gets smaller and smaller and smaller and smaller. Okay, that's your AFC. So you should be able to identify your cost curve. Let's put in the AVC, and the AVC has a U-shape. So the AVC has this shape like a U. The average total cost also shapes like a U. Suppose I came here and I did this. Both of them look like U's. How would you know which one is which?
The lower one.
This one is which one? How do you know that? If you remember here, average cost is AFC plus AVC, which means the average cost is always going to be higher than the AVC, or AFC is never negative. So once, even though you know both of them look the same, you should know that the AC will always be sitting on top of the AVC. Because AC is AFC plus AVC. And since AFC is never negative, even if I don't label them, please don't ever do this. Mathematically, this can't happen. Okay? So the AVC will sit below the AC. Yeah? Last one is the marginal cost curve. And this one...
And both of those will always have a curve, right?
I'm sorry, say that again?
Both of those will always have a curve?
U-shaped, yes. And then the marginal cost curve kind of looks like this. And notice I'm putting an X because the marginal cost will cut the AC and the AVC at their minimum point. So let it cut it in the bottom of the U. Don't do like this and this. Let it cut it in the bottom, as close as you can. So MC needs to cut AC and AVC at their minimum points. For me, MC kind of shapes like a check mark. That's how I identify it. It kind of looks like a check mark, and it cuts those other two curves at their minimum points. We're going to use these cost curves to death over and over and over again. So you got to know how they shape. The market structures that we will do, we will use the cost curves along with a whole bunch of other stuff. So you're going to have to know why they shape the way they do. Now the last thing I'll do related to cost is this. A lot of students ask me, why is the AVC shaped like a U? Why do we have this relationship where MC cuts AC and AVC at their minimum points? Why do these curves shape the way they do? If you remember at the beginning, and I kept saying this, the pattern in costs is determined by the pattern in production. So whatever we see happening in production, we could use that to map out what will happen in terms of cost. The last thing I'll do is I'll tie the production and I'll tie the cost together. Patterns in production, how do they dictate certain patterns in costs? I'll show you. So where are the cost curves coming from? They're coming from your production patterns. So, let me show you what I mean. So linking production. You want to remember patterns in production will lead to patterns in cost. Alright, here we go. You know it's about to get gnarly. So stack them the way I have them. I'm going to put the production up here. I'm going to put the cost up here. So the first one I'm going to do is I'm going to look at average product. That's the first production one I'll look at. Average product, kind of like the productivity of a worker. If you remember when we drew it out, the average product kind of sort of look something like this. So the productivity of a worker. And as it's going up, this is the productivity of the worker rising, hitting the max, and then the productivity of the worker falling. Now where this is at its maximum, kind of take it down a little. If you think about it conceptually, what's happening is this. The productivity of the worker is going up. Kind of like the worker is giving you more and more. Which essentially kind of sort of means this worker is actually costing you less if you think about it. So you hire a particular worker and they're giving you more and more. Their productivity is rising and rising. Essentially, this worker is actually costing you less and less. So as average product is rising, it necessarily means if you want to look at what's happening cost-wise, that's falling. As the productivity is falling, essentially you hire this worker and they're giving you less and less, then technically this worker is costing you more and more. What we know in econ is the mirror image of production is actually cost. Like in the mirror, you're trying to touch this ear, but you're touching this ear. Flip over production or look at production through a mirror and you actually get cost. So where we have an increase in productivity, we're having a drop in costs. Where we're having a drop in productivity, we're having a rise in cost. This is actually your average variable cost curve. Production and cost are mirror images of each other. Same thing with marginal product. It kind of sort of looks like this. You hire an additional worker and you're actually getting more from this additional worker. They're increasing output. So hire one more worker and the extra output you get is rising and rising. Then technically the extra cost you're taking on is actually falling and falling. So hire one more person and they're actually giving you more and more. The marginal product is rising and rising, and technically the additional cost that this worker is putting onto the business is actually going down and down. Again, mirror image of production is cost. So this, look at this in a mirror, is actually your marginal cost. Patterns in production determine patterns with cost. Let me see if you're thinking a little bit. If I was to take these two and put them on one graph, the production, if I put AP and relationship with each other, MP and AP, do they interact in a certain way?
Yeah.
Yeah? How?
When
Alright, that was a long, awkward pause there. Go ahead.
MP goes through the peak of AP.
Very good. Marginal product cuts the average product at its maximum point. So if I was to put these on one graph, let's say like this, that would happen. Yeah? Now, if the mirror image of AP is AVC and the mirror image of MP is MC, when I put these together, what does that mean? So you just told me MP is gonna cut AP at its maximum point. We just went through, this is the mirror image of this. This is the mirror image of this. So what will happen? The marginal cost is now gonna cut the AVC at its minimum point. Yes? But the main thing I want you to get is, this is the max, this is the min. This is the max, this is the min. Cut it at its max, this will cut it at its min. Yeah? And usually to identify MC, it kind of looks like a check mark because we tend to kind of cut off the upper portion because nothing really happens there. But technically, it kind of looks like the hill too. Yeah? So when you see this, you're going, what the hell, why is this happening? The story of cost comes from production. The mirror image of production is cost. So anything that happens in terms of production, flip it over and you get cost. If you remember, the law of diminishing marginal product, what did that say? Can you read that to me again? The law of diminishing marginal product.
If successive units of a variable resource is added to a fixed resource, first the additional output will increase, then decline, and even become negative. Good.
So, basically the law of diminishing marginal product is explaining the shape of the MP. So keep on adding the variable resource to the fixed resource, you get the extra output, gets up to be high, then it starts to get low. Which means technically, the law of diminishing marginal product, which defines short-run production, is also defining cost curves. Since the mirror image of production is cost, whatever happens in terms of production, flip it over, and you have an explanation for how cost behaves. So the cost curves are not random. We don't just pick them up. They are tied to production patterns. Okay?